Introducing NextGen's 3000 kilonewton universal testing system. This is the main unit, which features a 4-column structure with the oil cylinder mounted at the top. The pistons measure 23.6 inches or 650 millimeters. The system includes a load cell with a 3000 kilonewton capacity, and both the upper and lower grips are hydraulically operated, utilizing double-sided action tensile grips. The tensile grips are suitable for testing both flat and round specimens. The machine can perform tensile testing on steel tubes or rebar material and can also be used for compression and bend testing. This UTM has a net weight of 38,000 pounds, 19 tons, and stands at a total height of 4.2 meters, 13 feet and 9 inches. This is the power pack for the UTM. This is the loading cell control box, remote control unit, and Tensile software. When the universal tester is first received, begin by erecting the machine and placing a wooden block between the fixtures. Only after this should you loosen the nuts to remove the steel plates. It is essential to follow these instructions to prevent the upper head from dropping down. Please adhere to these safety instructions. On the back of the UTM, there are a lower limit switch and an upper limit switch. When the unit makes contact with either limit switch, it will automatically shut off the motor. Power transformer supplied with your unit. Please connect the main unit to the power transformer. The transformer has an input power rating of 25 kilowatts with a 3-phase input of 480 volts at 60 hertz. The output is 3-phase 380 volts. Additionally, there is a single-phase output of 220 volts. The supplied testing machine is a 3-phase unit operating at 380 volts. You will find 3 ports labeled with 480 volts. Please connect the transformer to your power source using your preferred connection cable for the 3-phase 480 volts. The output is 3-phase 380 volts. This is the live line, and this is the neutral line. This is a single-phase 220-volt outlet. It is connected to the power socket for the computer, printer, computer monitor, and the cell control box. Please connect these devices to this power socket. The input is 480 volts and the output is 380 volts. The power supply for this power pack is 3-phase, 380 volts. The power supply for the 2 motors is 15 kilowatts. This is the hand-controlled remote system, which needs to be connected to the power pack. The accompanying power cable is designated for this connection. It should be linked to the power transformer supplied with your unit. The power transformer has a three-phase input of 480 volts and an output of three-phase 380 volts. This is the power unit responsible for connecting the hydraulic pipes. We have labeled the pipes for clarity as follows: A0, B0, A1, B1, A2, B2, C1, D1, C2, and D2. These markings are intended to simplify the necessary connections. The pumps are used for clamping and releasing the clamps, while the other two pumps control the oil cylinder. The left pipe connects to the upper section, and the right pipe connects to the lower section. Before the unit arrives, please ensure you have prepared anti-wear hydraulic oil. The oil should be filled through this filler hole. Please use 400 liters of ISO VG46 oil. The oil level indicator will help you determine when the oil has reached the appropriate level. This cable connects to the cell, and this connector connects to the cell control box. This is the cell control box. This is the power cable for the single-phase 220-volt supply. The control output connects to the power pack, which is linked to the cell. This is the displacement port, which connects to the main unit's encoder. Additionally, this is the communication cable, which connects to the computer. And this is the limit switch. Connect the limit switch cable to the main unit. This is the back of the computer. The white communication cable connects to the cell control box. This port is designed for connection to the 3,000 kilonewton load cell, while this other port connects to the extensometer. When the client receives the universal testing machine and connects the hydraulic pipes, there may be air present in the lines. The first step is to exhaust the air from the pipes. The simplest way to do this is by using the hand control box, which controls the piston's movement. Select your preferred speed and move the piston up and down about 5 times. This will effectively remove any air from the hydraulic pipes. The upper and lower double-sided action grips may also contain some trapped air. To release it, use the hand control box to open and close the clamp, approximately 5 to 6 times. After releasing the air from the grips, press the clamping button to return the piston to its initial position. Once it resets, click the clamp button to ensure the clamps close simultaneously. To verify synchronization, you may use a ruler to measure each side's length. If you notice that one side moves faster or slower than the other, a simple adjustment may be needed. At the back of the clamping fixture, there is a hand wheel that allows for the necessary adjustments, helping to ensure proper synchronization during the clamping procedure. To check the synchronization of the 2 hydraulic cylinders, you may use a ruler, positioning it at fixed points. Clamp and release the fixtures to confirm they move at the same speed. Start by ensuring the clamping fixtures are synchronized in the clamping direction, then verify their synchronization in the opening direction. Make adjustments as needed to ensure smooth synchronized movement in both directions. This is the backside of the universal testing machine. To simplify connections, the connectors are labeled A1, B1, B2, and A2 at the top, with C2, D2, D1, and C1 at the bottom. The 2 outer connections are designated for clamping, while the 2 inner connections are for unclamping. Clear markings and arrows above each connector indicate their specific functions to assist the operator. These are the hand wheels, which can be adjusted using a wrench. Rotating the hand wheel clockwise will slow down the movement, while rotating it counterclockwise will increase the speed. The same adjustments apply to the bottom clamps. C2 and C1 are for clamping, while D2 and D1 are for unclamping. Before the delivery of the universal testing machine, the unit is accurately calibrated, and the upper and lower Tensile grips are carefully adjusted to ensure synchronization. Upon receiving the tester, if you notice any deviations, you can make small adjustments to re-establish grip synchronization. Typically, only minor adjustments will be necessary. When installing new Tensile jaws, the operator should be mindful of when to tighten the screws to secure the jaws, as shown here. Do not tighten these screws first. If the tensile jaws are not properly aligned, use the hand control box to clamp them. This will ensure the jaws are connected correctly. Once connected, you can lightly tighten the screws. When testing a sample, open the tensile jaws and place the test sample between them. Once the jaws clamp onto the sample, tighten the upper 2 screws and then the lower 2 screws. This will provide better alignment for the unit. When installing the tensile jaws, please ensure the markings are correctly positioned. For example, the markings on the bottom jaws should be at the top, as shown here, while the markings on the upper jaws should be at the bottom. If they are not positioned this way, adjust the jaws to align the markings as specified. A round bar is provided to assist with aligning the upper and lower tensile jaws and will be included with your main unit. An Allen key is also supplied for loosening the screws. Before clamping the round bar, use the Allen key to slightly loosen the screws while preventing the jaws from falling out. Please pay extra attention to this step. Once the screws are slightly loosened, clamp the upper and lower sections of the bar to help align the jaws. After completing this alignment procedure, use the Allen key to securely tighten the screws. At this point, your tensile jaws should be aligned. Click New to input the sample information. Here we will import the sample dimensions. When importing the size, you may include the width multiplied by thickness. The section area will be calculated automatically, and the gauge length is set to 50 millimeters. Once entered, click OK. You will notice a negative force load when clamping the sample. Please do not zero it. Instead, zero the displacement. You may use displacement control to adjust the displacement speed as needed. For example, you can set the test speed to 5 millimeters per minute and then click Start to start the test. After the test is completed, the sample will break. The test results show that the maximum force is 519 kilonewtons. Both P1 and P2 are adjustable. This is a 3-point test fixture. The upper section includes a rod that is securely gripped by the hydraulic grips. Below this, the 3-point bend fixture is positioned. The upper crosshead is inserted into a plate and fixed in place with a nut. The lower span is adjustable, and once set to the desired dimensions, it can be locked by tightening the nuts. At the base, another rod is firmly clamped by the hydraulic grips. These rods are positioned to ensure vertical alignment. Closing upper hydraulic clamping fixture. Closing lower hydraulic clamping fixture. Opening lower hydraulic clamping fixture. Opening upper hydraulic clamping fixture. The maximum clamping pressure is 25 megapascals. Before testing, the client can select the appropriate clamping force based on the sample's maximum testing force. Typically, the clamping force should be greater than the sample's maximum testing force to ensure a secure hold. This panel allows you to adjust the clamping pressure with a maximum setting of 25 megapascals. When clamping the sample in the tensile grip, you can select the appropriate clamping pressure, adjusting the upper and lower clamping pressures independently.